moving forward with timeline of major architectural styles, and right now we'll discuss the Renaissance. The Renaissance architectural style started somewhere between 1400 and ended around 1600. That's when the Baroque architectural style went into play. So let's talk about Renaissance and what is actually interesting about this architectural style, and how this style is different from Gothic and Romanesque, and what kind of cues it's taking from other styles that were before it. So we have a couple of examples here, and those are photography, obviously, and drawings that show what this architectural style is about. There's few things that we need to mention when we're talking about Renaissance. So the first thing is, as you can clearly see, this architectural style was adapting classical Roman and Greek architecture, and the St. Peter's Basilica, which is right here, you can clearly see where those influences are coming from. You can see the Corinthian order of columns. Those columns are not evenly spaced, so the use of the classical Roman or classical Greek style was more liberal, and there were more shortcuts or design choices taken that were not constricted by whether it was the Doric or Ionic or Corinthian orders. So those orders were taken slightly with slightly looser interpretation. So you can see that we obviously have influences coming from classical Roman and classical Greek, and when we look at those drawings that we see right here, we see why it's that. Obviously, Corinthian order used in those constructions, and even some cues of how the construction would look like from the top. Basically, what kind of layout it would have is very similar to what Roman and Greek classical architectures would be about. Another thing that is really important about this style is the symmetry and an obsession about ideal proportions. So when you look at those constructions, and again, St. Peter's Basilica, which is probably the best example of this architectural style, you can see that everything is very symmetrical and proportional. So the dome itself, there's a lot of symmetry going on here. Even the columns are placed in the correct place. The placement of sculptures and windows, and almost every detail that you see here is super symmetrical. The whole courtyard that is right in front of it as well is very symmetrical and very and it's driven by geometry. And this is another great example that shows the layout of the construction and how it's being built just around circle and half circles. So this is really important. Geometry is taking a really important place in this architectural style. It's almost obsessed with geometry. Again, here you can see that almost everything is based on a symmetry, whether it's a vertical or horizontal symmetry. Almost every room looks the same. It's almost like a mirror of each room is happening right here. Very simple symmetry forms, very simple geometrical forms, and almost ideal obsession about proportions and everything. So those are the major points. Also, what is interesting to be noted, that this style is very modular. So this is a great example where you see the rooms themselves, and the staircases and entrances, because this building itself has like 4 of the entrances. Those look exactly the same. So for instance, if you would build just this one block right here, you would just be able to repeat it and place it on all corners or on all sides. All those sides would look the same. Minor details in terms of what kind of sculptures would be sitting on top or decorating those constructions obviously would happen, but the construction itself would be almost identical. So the modular part means that you can pretty much take this, for instance, one block or maybe this one room and duplicate it, and it's going to look exactly same. If you mirror it and duplicate, it's going to be exactly same room somewhere else. And that's really important, because when you look at the layouts of Renaissance constructions, they seem to be following that logic, where a lot of those things are repeating themselves, and you can see the rooms that are being very similar, and the symmetry and obsession about the geometrical forms and how modular those things are. There's a repetition going on, and again, like for instance, when you look at this cathedral dome of Florence, which is done in Renaissance style, you can see that you could pretty much cut out this one piece of a pie right here, and when you copy it enough times, it's going to create this whole dome. So that's really important thing to mention, and notice that those things will be repeatable. Obviously, again, small details like those balustrades right here and entrances and windows, all those small details will vary, but the general forms, like even those half domes that we see here, those mini towers or attachments that we see here, all of them look exactly the same. They're just repeated a couple of times, and that's where the modularity comes from. Even that little dome that you see right here almost seems like a baby offspring of the larger dome, which is right here. So if you just scale it down and maybe remove some details, you're still having pretty much the same construction. Interesting part about the modularity of this architectural style is the fact that in video games, a lot of things that you will be building, whether it's architectural buildings or parts of constructions, or maybe even natural forms, all of them have to be somewhat modular and repeatable, because there are limitations whether you do it whether you work for console games or PC games. There's memory limitations or graphic card limitations that will dictate how much stuff can happen on the screen, how many things can be crammed in into the screen, whether it's a texture resolution or the amount of texture memory on the screen. All those things matter because it will just tell you that maybe when you want to introduce a construction like this, you would have to be really careful, because if you would build everything uniquely, it will be very hard for a console to run it smoothly. You have to take into consideration the fact that art is only a small chunk of the whole video game. There's a lot of calculation that are taking the memory, whether it's a CPU or cores or whatever, depending on the console structure. The resources are taken for everything: AI, gameplay, lighting, texture memory, animations, geometry count, how many polygons can happen on the screen, how many characters you're going to see on the screen. All of those things contribute to the final game. And when you build a construction in the game, you're going to have to build it modular. So you can take this one piece and make instances of it that will use exactly same texture, but maybe some decals that will be placed on the texture itself, maybe some little discoloration that can happen as a separate, smaller, low-res textures, will make this construction look very unique, not so modular anymore. But my major sort of feedback here is the fact that you can take this idea that comes from the Renaissance architectural style, the modularity of it, and basically apply it directly into video games, because video games are very modular in a way how you construct those things. So, and that might be one of the things that when you work as a concept artist and you create images and construct things, maybe construct and concept architectural elements, those elements will have to follow that very same logic. Okay, so let's talk about lighting. There's two types of lighting that I wanted to discuss in this lesson. First one which we see right now on the screen, is called a ambient light. And there's a couple of things to understand and know about the ambient light. It's basically the light that is coming from many directions. There is no specific directionality of light. The ambient light would come from almost like a dome of color that is being projected on your 3D space. So for instance, if you have your 3D space like right here, you are going to have a dome around it like this, and this dome will pretty much from every direction, it will project a light. So every single point on that dome will project a ray of light, and this ray of light is basically going to go across this construction that we see here, for instance. And what's going to happen is, because there is no specific directionality of light, what you're going to achieve is something that is called ambient shadows or ambient occlusion. And basically what it means is that the shadows are going to be very soft, and they're going to appear only or mostly in places where the objects that you see right here are closest to each other. So for instance, when we look at this red sphere and it's sitting on the ground, you can see that this red sphere is where it's touching the ground, it's creating the most of a shadow, and the shadow is very soft, very diffused. Much like those columns, as close as you get to a bottom of that box right here, you can see the columns are getting darker and darker, and especially also right here, right where the capital is, you can clearly see that it's those areas are much darker. Those two boxes that sit on top of those 6 columns, you can see they are not connected perfectly, and the distance between here and here, right, is so small that this line or this space in between is going to be really dark, because the ray themselves are not able to reach that area so much anymore. When you think about ambient occlusion, you have to think about how light rays are working and how basically light is working. So when you have a surface, and let's draw like a little surface right here, and you have a ray of light that is hitting the surface, what's going to happen is the ray of light is going to reflect in one direction. Now, this is ideal situation for very glossy, almost very specular surfaces, which mean one of the best examples could be a mirror. So every single ray that goes and reaches the mirror is going to reflect directly and going to create perfectly sharp reflection. When you, however, get to be working with a diffuse material, this reflection is going to scatter, which means it will be broken down into smaller rays that have less power, and basically the result is very blurred reflections. And the same way it works when you have a surface and the light is hitting it. So maybe let's draw on this side, and let's make a surface like this. So the light rays that are hitting here, you can see that there's quite a few that can squeeze between, right? But then that's pretty much it. And those light rays will start losing energy as they bounce around. Remember that all the lights are basically bouncing around. So you can see that those rays will eventually start there's going to be a diminishing return, or the light power or the bounce of the light, the energy of the light will start to be smaller and smaller, and eventually it will disappear. So there's no light, let's say right here, there's really little light coming in here. So what you're gonna have is this gradient that, this area right here, where you have all the light rays hitting the surface directly. Let's say they will have 100% brightness, but as soon as the light bounces in this area, the brightness will be, let's say, 80%, and in this area is going to be 60%, and right here it's going to only be 40% because there is no direct light hitting here anymore. And then in here it's going to be 20%, and so on and so forth, eventually reaching 0%, where there's not enough energy coming from the light to create enough light information so that you can actually see color and surface property. It's just going to be really dark here, and this is exactly what's happening here. This space in between is very narrow, which means not that many light rays can reach it, and eventually just becoming really dark really quickly. Whereas here in the open space, there's enough rays to hit those surfaces to give you still those very soft gradients without going too dark. And that's exactly what is happening. That's exactly what is happening under the ball. So the amount of light that is bouncing right here is very little, right? Where the amount of light that is bouncing right here is much more. And here is just like purely, there's a lot of rays and a lot of rays. Again, think about all of those rays coming from different directions, which means one will come from this direction, the other one will come from this direction, one from here, and one from from behind your chair, one from the depth of the image. So in this area here, you're gonna have light rays that are coming mostly from this direction and maybe from the sides, but those rays that are coming from the center of the image or from the depth of the image will be occluded by this structure right here and those columns and the sphere itself. And thus, when you look at the surface itself, you can see that it's slightly discolored and just darker, basically. And that's pretty much how ambient light works. When you think about ambient, okay, so let's talk about lighting.